Bioprinting is a new technology which combines printing of 3D structures with biology. Having a heart problem? Let's just print a new one and transplant it right away. But is this really possible? What do scientists think about this?
Organs can vary a lot in tissue complexity. Take an ear, for example, which is composed of skin, blood vessels, and cartilage. Other organs, like the liver, are much more complex, as they contain multiple different tissues and cells that are so complex, forming a multifunctional tiny unit, which is really difficult to replicate. One of the biggest problems that we encounter is how to balance the technology with the biology. Cells are very delicate, and slight changes in the environment can damage the cell. To protect the cells and give them an environment that they also encounter in the body, they are mixed with nutrients, which are also called growth factors, as well as bioinks. These can be softer gels or harder biodegradable plastics. This mixture then has to be pressed out of the printing cartridge using pressure, electric currents, or sound waves. Once extruded from the printing cartridge, the mixture has to be solidified using pH or UV light. All of these print settings have to be tweaked really carefully to make sure that the environmental changes are reduced and therefore we don't have that much cell death. Many great advances are the result of a long sequence of experimental trial and errors. Examples of printed bone and cartilage are promising. They are good enough to patch up small damage of simple tissues in animal trials. But it may easily take another 20 to 30 years before we can print full and complex organs for human patients.
In the lab, it's difficult to keep these tissues alive for more than 4 weeks. However, devices have been developed which mimic the body's conditions, allowing us to use printed tissue pieces for drug tests and disease development. Complications aside, the future of the field is exciting. Organ factories are far, far away and will likely remain science fiction. But the technology of bioprinting offers new avenues for personalized medicine, tissue development, and cancer research.
Not bad.
Oh, you got all the words out. Now we just clean it up.
Okay.
I didn't do anything.
It's all your fault.
Vivian, I'm standing here recording you and your sister making these
Wow.
making these beautiful images. Oh boy.
Oh, this is so much fun. Can we get it back? Yeah, get it back. Oh, I love this.
Degradable plastics. This mixture then has to be pressed out of the printing cartridge using pressure, electric currents, or sound waves. Once